Hi, and welcome to the 7th section of this course, Recurrent Neural Networks and LSTM. The section will demonstrate the following topics: Recurrent Neural Networks, a fundamental component, gate operation and its steps, TensorFlow LSTM useful classes and methods, univariate time series prediction with energy consumption data, writing music a la Bach. Now, we will see the first video of Section 7, Recurrent Neural Networks. In this video, we will learn about few topics, that is, exploding and vanishing gradients, LSTM neural networks. Knowledge doesn't normally appear from a void. Many new ideas are born as a combination of previous knowledge, and so that's a useful behavior to emulate. Traditional neural networks don't include any mechanism translating previous seen elements to the current state. Trying to implement this concept, we have recurrent neural networks, or RNN. Recurrent neural networks can be defined a sequential model of neural networks, which have the property of reusing information already given. One of the main assumptions is that the current information has a dependency on previous data. In this figure, we observe a simplified diagram of an RNN Basic Element called cell. The main information elements of a cell are the input, xt, a state, and an output, ht. But as we said before, cells have not an independent state, so it stores also state information. In this figure, we will show an unrolled RNN cell, showing how it goes from the initial state to outputting the final hn value, with some intermediate states in between. Once we define the dynamics of the cell, the next objective would be to investigate the contents of what makes or defines an RNN cell. In the most common case of standard RNN, there is simply a neural network layer which takes the input and the previous state as inputs, applies the tan-h operation, and outputs the new state, h, open bracket, tau plus 1, close bracket. This simple setup is able to sum up information as the epochs pass, but further experimentation showed that for complex knowledge, the sequence distance makes difficult to relate some contexts. Seems like a simple structure to remember, but the context needed for them for being associated requires an increasing sequence to be able to relate both concepts. This also brings the associated issue of exploding and vanishing gradients. Exploding and vanishing gradients. One of the main problems of recurrent neural networks happens in the back propagation stages. Given its recurrent nature, the number of steps that the back propagation of the eras has is one corresponding to a very deep network. This cascade of gradient calculations could lead to a very non-significant value on the last stages, or in the contrary, to ever-increasing and unbounded parameter. Those phenomena receive the name of vanishing and exploding gradients. This is one of the reasons for which LSTM architecture was created. LSTM neural networks. The long-short term memory LSTM is a specific RNN architecture whose special architecture allows them to represent long-term dependencies. Moreover, they are specifically designed to remember information patterns and information over long periods of time. Nice! We have successfully learned about recurrent neural networks.